Well, hello everyone and good evening. This is your girl Audrey Codner from ACG Math Tutoring. And I just decided to come live just to give you a small snippet of what I've been doing for the past couple of months. So, what I've been doing is going live on TikTok and basically talking about certain areas that a lot of the students were really struggling with. So, today I'm going to take you on a ride for geometry and we're going to be looking at central and inscribed angles. So let's take a look. So first off, we have a review basically of central and inscribed angles, whereas the central angle, the measure of the angle which is formed, the vertex, is at the center of your circle. So if your vertex is at the center of your circle, that means the measure of this angle is equal to the measure of the arc, not the arc length, the measure of the arc. Okay, a lot of people generally get that wrong. Now, if we want to go with an inscribed, that means its vertex is on the circle, not the center of the circle, but on the circle. And the measure of this angle is half of the measure of its arc. So I'm going to go through a few examples just so you can get it, just get an idea of it. So we're trying to find the measure of arc AB. Anytime they're giving you two letters, that means they're talking about the minor arc here. So they're going from A to B. So if we're saying the central angle is 110, that means the measure of this arc is also 110 degrees. But now they're asking us to find the arc of ACB. So if I'm starting at A, I need to get to C. So this way is not the way to go. So I need to go to A, then the next letter I should hit is C, then B. So when they give us three letters, we're looking at a major arc. So if we know that out here, this arc here is 110 degrees, we need to figure out what the measure of this major arc from A, C, B is. Now, the circle is a circle no matter what, how big the radius is and how big in size. The measure of a circle is always going to be 360 degrees. So if we got a full circle of 360 and we know that from here to here is going to be 110, we will subtract those two. So that means we have 360 degrees minus 110, and that will give us the measure of arc ACB. I know, I can't emphasize it enough. So that's going to be 250 degrees. So I'm going to put that little M because it really should be the measure of it. So we have 250 degrees. Okay. Hey, thanks so much for chiming in. All right. So a couple people are flashing. I'm like, hey, Audrey. I'm like, hey, how are you doing? So I am definitely going live on Facebook, going live on, where am I? YouTube and LinkedIn as well. So if you have kids, if you know someone that is trying to get their GED or maybe trying to get the acuplacer, raise up their score for the ASVAT, this will be the live for you. All right, so now I'm taking a look and we need to find the measure of angle C. So the measure of angle C is right here. So we know a couple of things. One, they're giving me the diameter. A diameter is a chord or a segment that goes from one point of the circle through the center of the circle to another point of the circle. All right. So this is giving me basically half a circle. So like I mentioned earlier, so let me slide that over, that if we're saying half of the arc is basically the measure of your inscribed angle, or twice of the inscribed angle is the measure of your arc. So if I'm giving the angle, which is at 25, that means the measure of this arc, and I'm going to put it out here. So the measure of this arc BC because if I go BAC, that gives me this angle right here. But the arc of BC is going to be twice the angle that they gave us. So arc BC, that's going to be 50 degrees because 25 times 2 gives me 50. But as I mentioned, they gave us the diameter and it's going through the center of our circle. So if we're saying from this point to this point is 50 degrees for that arc, then what will be the remaining if I let that go? So hopefully you're probably saying, well, if that's the diameter, that means from ABC, this whole thing here, that should equal 180 degrees because that's half of a circle. So if I know part of it's going to be 50, that means what remains is going to be 130 degrees. So we can say the measure, okay, not even the angle, oops, the measure of arc BC, AC, or AB, there we go, been doing this all day, is 130 degrees. But is that what they asked for? No, they didn't just ask for what that missing piece is. They asked for what is the measure of angle C. So anytime you're doing any kind of problem, always take a moment to look right back at the question to make sure that you're answering the question. So we know arc BA is going to be 130 degrees. And it's associated with angle C, which angle C is your inscribed angle. So that's telling me that this arc of 130 degrees, if I divide it by 2, that will give me the measure of angle C. So 130 divided by 2 will give me 65 degrees. So that is my official answer. So we had to use what we know about inscribed angles to find this bit of the arc. Then we had to figure out what a semicircle is, so we can figure out the remaining part of this arc. And then we had to take half of the arc in order to find our inscribed angle. All right, so let's take a look at the next one. So we need to find the measure of angle A. So angle A is right here. That's an inscribed angle because my vertex is not at the center of the circle. But we're going to use this information to help find angle A. So right away, I'm noticing that this angle right here, they're saying is 90 degrees. That's central angle. So if the central angle is 90 degrees, that means arc BC is also going to be 90 degrees. Every time it's a central angle, there we have its arc. So now we want to find that inscribed angle. So how are we going to do it? We're going to divide by 2. So you have your 90 degrees. Divide by 2. That gives me the measure of angle A is equal to 45 degrees. Okay. So now we want to take a look, and it says find the measure of ACB. So I'm seeing 3 letters. That means that must be a major arc. So AC, nope, this other way, ACB. Good. So if we're looking at this part of the arc, And they gave us the opposite, AB. Arc AB is going to be 170. So if we know that one side is 170, and we know that a whole entire circle will give me 360, so 360 minus that 170 gives me the measure of this arc, which is 190 degrees. So now they want us to figure out what is the measure of angle AOB. So AOB. O is my vertex. O is at the center of the circle. So that means angle AOB has to be a central angle. And if it's a central angle, that means its arc is the same measure. Please do not get this mixed up by arc length. Okay, there's too many people that lose points on any kind of assessment because you keep forgetting that this is dealing with measures, not arc length. So that means the degrees is going to be 170 degrees. All right. Not too shabby. All right, so now we're kind of taking it a little bit further. So if I notice, most of my activities or my angles are all happening surrounding the center of the circle. So that means I'm going to be having some similar measures of the arcs. So they're telling me find measure DC, find the measure of arc EAB, find the measure of the major arc ACB, and find the measure of the angle AOB. So they're giving me some information. They're telling me that arc AE is 110 degrees. So if that's 110 degrees, that means this angle AOE is also 110 degrees. I like to mark up my diagrams before I touch anything. Now, they're saying that this angle BOD is 50 degrees. And since it's a central angle, that means this arc is also 50 degrees. So now they're kind of giving us some additional information. So instead of looking at it as one big whole circle, let's break things up. Let's focus right here. So this is 110. And right now, I have this segment, the diameter of AC, okay? So that's going right through that center of the circle, and it's going from one point of the circle to the other. So we have a diameter. So that means it's creating a split of that circle. So if we know that this angle, angle AOE, is 110 degrees, then what's the measure of EOC, angle EOC? So hopefully you guys are like, oh, that's easy. That's 70. It's like, awesome. So if this angle EOC is 70 degrees, and that's a central angle, that means this arc is also 70 degrees. So now taking that away, we also got some additional information. What else is it showing us? Well, angle EOC could take a gander of being close to AOB. Now, I know we can't go by just looks. We need to get some additional information. But I think when this was constructed, I think that's what they had in mind. But it looks like we can go with vertical angles this way, especially with right angle AOB. And we're going to say it's a vertical angle with EOC. I know we can do some more processing, but I just want to get the essentials down. And then you're probably saying, well, hey, Audrey, if we're going to do that, then don't you have vertical angles right here? And I would say, yes, we do. So with that being said, then I can say angle AOB is also going to be 70 degrees because they're vertical angles, and vertical angles are congruent. But then I can do a little bit of math to try to figure out what will be my remaining COD, angle COD. Because if we're saying that DOB is 50 degrees, and we're looking like AOE is going to be a vertical angle with COB, so all we have to do is take 110 minus that 50, and we'll get 60 degrees. And if we want to double check, let's say 60 plus 50, that's 110, plus 70, that's 180. Because if I cover that up, that's also going to give me a semicircle. So 180 degrees. So now that we marked up our diagram, now we can answer our question. So we want to know the measure of DC, arc DC. Well, if the central angle is 60 degrees, that means arc DC is also 60 degrees. We want to know that the measure of arc EAB. It's a major arc because they're giving me 3 letters. Here's E, here's A, here's B. And if we notice, EAB, that looks like a semicircle. Let's see. If I cover that up, I got my E, got my A, got my B. Yep. And that's going to equal 180 degrees. Because if their central angles equal 180 degrees, so does the arc. So now we want to find the measure of arc ACB. Okay, so we're saying ACB. If I go this way, the B comes next. Oh, no, no, no. That means we have to go the opposite way. So that's our A, that's our C, that's our B. So the easiest way, we will take our 360 because it doesn't include the 70 that we just found. So couldn't we do 360 minus 70? Doesn't that sound like, or I mean, you can add them all up. You can put the 60 degrees right here. We can add the 110, the 70, the 60, and the 50, and we'll get the same answer, right? So if we do our subtraction, or if we do our addition, we're still going to get 290 degrees. And then last but not least, what's the measure of angle AOB? Well, we found to be 70 degrees. Okay. So as long as we kind of stay true to what's going on, we'll be able to figure it all out. So now, let's take a look at BC. What do we have here? So with BC, it seems like we have an inscribed angle because the vertex is not at the center of the circle. So what do we know about inscribed angles? Well, this inscribed angle right here is basically half the measure of this arc out here. So we're looking at arc BC. And luckily, that's what we're looking for. So if we know that angle BAC, which is an inscribed angle, is going to be half of this, couldn't we double or times this 85 times 2 to figure out that major or that minor arc there? Okay, so that's what we do. We take our 85 and we times it by 2. So 85 times 2, that gives me 170. And it'll be 170 degrees. Okay, so central angle is when your vertex is at the center. Okay, your vertex is at the center of the circle. Inscribed angle is when your vertex is on one side of the circle and it opens up. All right. So 3 more and then we are done. So taking a look at this one. Now, instead of just looking at an angle, we have an inscribed triangle. So guess what? We're still doing the same exact thing. Do not freak out. You're freaking out. Why are you freaking out? Just stop freaking out. Okay? Breathe. I would say put your head between your knees, but then you won't be able to see what I'm doing. All right? So take it step by step. We're supposed to be looking for the measure of angle C, right? And I know. She's like, she's doing math in pen. She's a rebel. Yeah, that's me. All right. So if we want to find the measure of angle C, we got to take on what they're giving us. They're giving us this angle A. And angle A is 55 degrees. Angle A is also an inscribed angle. Okay. So since it's an inscribed angle, you see its endpoint, which is at B, and another point at C. Okay. The vertex is here at A. So that means arc BC, that's going to be its associative arc. So if we're saying that the inscribed angle is 55, the arc is going to be twice that. So that means the measure, I can't emphasize it enough, so the measure of arc BC is going to be 110 degrees. All right, so out here is 110 degrees. And how I got that, I took my inscribed angle, the 55, and multiplied it by 2. But we're not looking just for that. We need to find the measure of angle C. So this means I need to take a look at angle C and see what is its endpoint. So here we got A, all right, and we got B. So we need to figure out what the measure of this arc is in order for us to figure out what the measure of angle C is. Well, if you haven't noticed, AC, that's a diameter. It's a segment or a chord that's going through the center of your circle. So that means if I cover this up, from here to here, that's half a circle. And half of a circle or a semicircle is 180 degrees. So if this part is 110, that means, yep, here we go with the 70 degrees again. So are we done? Nope. We found that the arc is 70 degrees because 70 plus 110 gives me 180. But we need to find the measure of angle C. So in order for us to do that, we have to take that 70 and we need to divide it by 2. We got to make it smaller. Okay, so when you're going from arc to angle, you're making it smaller. You're dividing by 2. When you go from angle to arc, you're multiplying by 2. Okay, so hopefully that helps a little bit. So 70 degrees going down half, which will give me the measure of angle C will be 35 degrees. Okay, so when you go from arc to angle, you divide by 2. When you go from angle to arc, you multiply by 2. All right, let's get with the next one. All right, so we need to find angle, the measure of arc, CAB. Okay, CAB. So it's a nice major arc. All right. And then we need to find the measure of arc ABC. All right. So this time we got central angles. So that means this angle AOC, its arc is also going to be 35 degrees. But we can find the rest. And how do we find the rest? We'll take 360 minus our 35, because a whole circle is 360 degrees minus the 35 that was given to us, which gives us 325 degrees. And that is the measure of arc A, B, C. Okay, so we found this one. So now they want us to find the measure of arc CAB. Well, if I bring out my piece of paper, I notice that this segment BA, okay, which is hitting right on two ends and going through the center of the circle. So that means from arc B to A, that's going to be 180 degrees right over there. So if they want us to figure out what CAB is, that's supposed to be a degree sign. Got a little crazy with it. Okay. So that means we got our measure of CAB. So that means we have our 180 plus our 35. Right? Because remember, we're just taking this small piece right over here, and then we're tacking on to that half or that semicircle. So that will give me 215 degrees. Okay, so that would be the measure of arc CAB. Well, so even though I'm just going through it, but just kind of remember, you just have to know the difference between the central and the inscribed. All right, so this is going to be the last one. Let's make it a doozy. Okay. Now, I know you're seeing some stuff and you're like, oh, good God, can't do that. No, you can. Okay. We actually did one similar to that not too long ago. So when we look at it, we want to find the measure of angle BOC. So here's BOC. So we want to find the measure of that central angle. And how do I know it's a central angle? Because its vertex is in the center of the circle. So with that being said, what are they giving us? Well, they're giving us angle BAC, and they're saying that that is 55 degrees. I'm like, all right, we can deal with that. But since they're given that, that's an inscribed angle because its vertex is hitting the circle. So that means they're giving me a point here and they're giving me a point here. So right away, I notice for B, arc BC is actually being created here. And if we know the inscribed angle and we're looking for the arc, that means we're multiplying. So that means we have our 55. I know the numbers are just like, okay, Audrey, you really could have done a better job with the numbers. Okay, so that means my arc measure is 110 degrees. Okay, so now knowing that, what is the measure of angle BOC? If you said 110 degrees, you're ready to rock and roll. Okay, because since it is the arc of a central angle, it's basically the same degrees. Okay, so not too long spending here. The only thing that you really need to understand is what is a central angle, what does it mean, and what is an inscribed angle. Okay, so with all that being said, all you have to do is just take your time. Okay. Once you see where your vertex lies and knowing and understanding the rules that when you have an inscribed angle and you're looking for the arc, you're basically multiplying by 2. But when you have an arc and you're looking for the angle, you want to divide by 2. Okay. Now, if you like the notebooks, not a shameless plug, I actually designed this notebook. Okay. So just like I was showing you through step by step, and I definitely have a couple of problems in here. Okay. Yes, I did was able to cut them out and put them in here and give myself some room. But also you have a section for your formulas. And then later on, if you want to write down the steps that you need to take, what should you look at first or second, you can do that. And then on the other side, you have more of a grid that you can do more graphs with, you can do more practice problems with. Like this, everything is basically essential in here. So you have places where if you want to draw, you can draw your own fractions. If you have like probability stuff and you want to actually put down your notes, you can put down your notes. And then we have some formulas. And then on the other side, the same thing is happening. You can put your extra problems over here. You can put your extra, graphs, figures, breakdowns, all that can be dealt here. Now, in addition to the 100 pages of notes, we also have this factor sheets. Now, this factor sheet goes from 1 to 200. So if you know you have a student that struggles with breaking down radicals, simplifying, factoring, and their multiplication is not that strong, you got this factor sheet that can go all the way to 200. This was designed for advanced students. This was designed for 7th graders all the way up to adults. So they'll have some time and some patience, as well as these are the most popular words that are being used in most word problems that will help you go from algebraic expression to a verbal expression. Then on top of it, the rules of integers. Let me see if I can shrink some of this stuff down. Okay, so you have the rules of integers, you got your addition, you got your subtraction, you got your multiplication. In addition to those, we have some of the linear and quadratic equations and their expressions here, just as reminders, as well as the order of operations from what happens in the US versus international. Then we have the properties of exponents. A lot of the students should be jumping onto this by now. If you're in Algebra 2, you should definitely be talking about exponents and looking at rational functions. Then we have the transformation, which a lot of kids in geometry dealt with that first semester, as well as the properties of quadrilaterals. Then, hey, our favorite, we got the SOHCAHTOA. There we go with the sine, cosine, and tangent, Pythagorean's theorem. And then as for my advanced students, you got all the different identities, as well as looking at volume and surface area. So if you're interested into this, unit circle is a must. If you're interested, I have it, the link to it on my website. So you can go to the link in my bio, click on my the link to my website, and then you could go directly to where it says the Ultimate Math Notebook. You can purchase your Ultimate Math Notebook. Summer is coming, so if you have a child that's going to go from 8th grade to 9th grade and you're kind of worried a little bit about how they're going to do with their math, you can actually reach out and join up with one of my courses. Okay, so you can like basically do like a prep thing. It's really self-paced, and then what I do is we do like a weekly check-in just to make sure that you're doing okay and to tweak their thinking. So that's all I have for today. And if you want to, I will be going live this evening on TikTok. Just been definitely going late lately. I'll be on roughly like around 9:30 p.m. So to help out with people that are on the West Coast as well. So if you need any assistance, just let me know. I'm gonna try to keep coming in here at least once a day. But today I had a couple cancellations, and so here I am. All right. So hopefully you guys have a wonderful day. And if I don't hear from you, hey, have a great Easter.